Good evening, everyone. Thank you for joining this session today. We are going to be talking about insurance as a domain and talk about a project related to insurance. How many of you are familiar with insurance as a domain? Is this going to be like a new topic for everyone? Okay. Any familiarity with insurance data sets or the field, guys? Has anybody got any idea? It's a very interesting problem statement, but even before the problem statement, like I normally talk about the domain, give you a picture about how analytics is done in the domain. This is going to be no different from other project sessions. I'm going to first talk about insurance as a domain, insurance analytics, what happens, what do people do, what do data scientists normally do, what are the different kinds of project you can expect, and then try to contextualize this project so that whenever you want to think about it later on or you want to talk about it, you can put this entire project in the right perspective. Okay, so we'll start by doing a quick round of domain discussion. So what happens in insurance, I'm sure everybody knows what insurance actually is as a product, but let's have a look at the basics first. So a customer comes along, customer decides to take a insurance product. What happens over here is that the customer is going to pay a premium to the insurance company, and then this will continue whenever there's an event. So this event can be whatever is the insured insurance is for example, if it's is life insurance, if the individual dies, unfortunately, then the insurance company is supposed to pay back the promised sum of money to the nominee of the insured individual. It could be for any other event, for example, health issue, automobile accident, car accident. It can be even your nowadays. I've heard footballers are insuring their various, I think their legs, the specific specific tools is for specific different professions. That it can be insured. In the US, people typically insure their homes as well, their TV sets, whatever. Most of it comes with insurance. Even nowadays, Ola has introduced something like a travel insurance. They charge you a rupee something for it. IRCTC has been doing it for quite some time. So insurance is basically the business of taking money from the insured individual or a group in terms of in the form of premium, and then when something goes the event actually happens, then a claim will be made, and then the claim is going to go to the insurance company, and the claim is received, of course, by the company, and then they will pay out, right? So insurance is the business of taking money from you and then paying out only when the event for which you're insured actually takes place. Okay, so question is that we often find that a lot of people come and tell you, especially in Policy Bazaar, we find that ad from Akshay Kumar too many times that just pay 500 rupees and get insured for 1 crore. Do any of you have you ever given it a thought that how is it possible that I can somebody takes a insurance policy of 500 bucks, pays for a few months, and then unfortunately, even if something happens, the individual can actually claim 1 crore rupees. So how does that work? So what happens is there's a mathematical law that's in action in case of insurance domain. It's called the law of large numbers. This law. So what they do is they will insure a large number of people, and only a certain number of claims can be expected from them. Okay. So out of capital N policies, small n claims can be expected, where small n is much, much smaller than capital N. So you're going to basically say that although there's a aspect of people can actually claim and get their money, but insurance companies spend a lot of time doing analytics on how many people are going to claim, if somebody is going to claim at all, and those kind of things. So these are some of the questions that they will ask. Okay, so some use cases, if you look at it, and this is one industry that heavily uses statistics and ML, very heavily. Insurance industry will use it primarily because they're always trying to figure out that what is the right price to charge you. So if you look at what is happening here, if you're insuring something, there's a certain premium uh, attached to it, right? You have to pay some money. The question is, insurance companies use a lot of math, a lot of stats to actually determine the right premium to charge for an individual customer or for a group of customers, whoever is getting insured, right? So that the risk of paying back the money is covered. So when you think about risk, right? Let me just add a note here. The difference between banking and insurance. So in case of say risk, right? In banking, the risk is when people don't pay back the money. When customers do not pay back. So in this case, where the customer do not pay back, where in this case, customer expects a payback. Is right. So it's a very can you think about like it's hugely profitable. So one of the major private players in India for insurance is SBI Life and HDFC Life. I don't know if you guys get a chance to think about investment, but you should definitely have uh, you know some of your investments in that domain. It's massively profitable because there's only a certain amount of money that ultimately will be paid back. Otherwise, all the money is practically free money for the company. So if like for example, I mean I have taken a term insurance, right? In my policy, if I'm alive after 75, it is a total loss. I better be dead before 75 for my family to get the money. You see, you see the challenge here. So it's hugely profitable for the insurance company as a whole. Okay. So now we're going to talk about certain basic terms I want you to learn. Frequency, severity are the two fundamental terms. Then we'll talk about pure premium. We'll discuss what is renewal, uh, what is pure premium, what is loss, exposures, etc. And then finally the relationship of pure premium with frequency and severity. Okay. So what is frequency? Frequency is that out of so many policies that you have, how many policies will result in a claim or how many claims will take place. Total number of claims divided by number of policy. That's the frequency of claim. Okay. I am putting a question across to all of you. Just think about it. Don't answer. We'll get to it when we get to it. If you were to build a model to predict number of claims, what regression technique will you apply? Don't answer, but just keep this with you as a question. Okay, think about it. We'll come to it and we'll discuss it later. Um, now, now comes severity. Severity is that whenever there are claims, right, how much money will be claimed? For example, if I do a car insurance and I insure my car for say 3 lakh rupees, right? If I claim total 3 lakh rupees, then I have to show that my car is completely smashed. It's a completely like total loss. Out of 3 lakh, how much money am I going to claim? So what is going to be the extent of my claim? So that is severity. So one, so look at the terminology. So frequency is number of claims. Severity is if you're claiming, then how much are you claiming, right? What is the average amount that will be claimed per claiming policy? So out of total number of claims, what's the uh, total amount that is there? So on a if you have say 100 claims being made out of uh, I mean total number of policies, 100 claims have been made, and for a total, if you take all the claimed amount, that comes to X. So X divided by 100 will give you the severity. Okay. Now comes renewal. Renewal essentially is the question that will the customer renew the policy or not. some people, some companies can focus on customers who do not likely to renew and then create a retention strategy. Essentially, you want to figure out who's likely to renew and who is not likely to renew, and you can go and create a strategy for getting more and more renewals, right? Okay, so there are projects or machine learning project associated with every single thing on frequency, on severity. So there will be modeling or machine learning activity done on severity also. Or you will have to do prediction on frequency also. Not on this project, but anybody working in insurance will be expected to do frequency modeling, severity modeling. Renewal is a dichotomous situation where a customer is going to renew or not. That is basically the classification uh, problem statement. Now comes pure premium. How much should be the pure premium? That's a question that insurance companies have. So if you look at a pure premium, that is defined as expected loss or expected money that is given out. Okay. So if you take the money paid out in one single claim, right? Or if if you sum it up across n different claims, so then you get the total loss or the total money that is given out, and you divide this by the uh, exposure actually. So number of policies that you have. So if you have 1 million policies, potentially 1 million people can come to you to make a claim, right? That is the total exposure of the insurance company, and then in the numerator you have got the total money that went out. Okay, so that's basically the pure premium. So if there are small end policies in a certain portfolio, it can be any auto life, non-life, etc. Then pure premium is basically 1 by n summation of xi, where xi is the loss from the ith policy. No questions?
So yeah, so is this PNC insurance we are talking about here, right?
Any kind of insurance, any, yeah, PLC or any, I mean, basically, you have n number of policies, right? Out of which some policies have resulted in a claim. Okay. So what you do, you take all of those claim amounts, you sum up the total money that has gone out of your pocket to pay back the claimants. Okay. And you divide that by the number of policies. That is basically the premium. So think about it like this, right? So today you decide to start insuring people too, so that you want to start an insurance business actually. So you start insuring for cars, right? And you said, okay, I want to insure 100 people. Fine. So you want to insure 100 people. What should be the policy pure premium that you want to, like, basically how much premium do you want to, like, minimum premium that you want to charge. So how do you want to get to that? You want to figure out your premium that you want to charge should cover for all the claims that will come to you. Yes or no? You need to meet the customer expectations, right?
Yes.
Right. So out of 100, say that by doing machine learning predictions, etc., you figure out that you are likely to have not more than 5 claims out of 100, 5% and 5 to 7%. Right. So you need to make sure that the loss that you incur out of those 5 or 6 cases, you want to distribute the total loss over the entire list of policies, right? So the money that 5 people will charge you, you need to make the rest, you need to distribute that loss over the entire portfolio of policies. So that is why you are basically going to take your total, the loss that is coming to you, the complete total loss and total money given out, and you divide that by the total exposure or total number of policies. That becomes your peer premium. That is the minimum amount you should charge.
Okay. So just hypothetically, just asking one more question.
Hmm.
So this is fine, right? When we have a data of that for particular year, how many policies being claimed and what is the premium being paid. So we could get this loss and what is the exposure. But then how about when somebody is just starting, don't be having, they are just going to get the premium. They are not, nobody has yet claimed. That time, how do they decide then?
Yeah, good question. So IRDA, regulatory authority, right? Insurance. So what they will do, they will have all these data. So they are going to have the frequency models for various portfolios. So you if you can get guidance over there. For example, what's the total death rate in India, mortality rate. I think for COVID it has really been skewed, but the total number of I think even I think the total number of deaths reported have also been very different. I mean, deaths due to COVID have gone up. Deaths due to other reasons would have really fallen down. So maybe the death rate hasn't really changed that much. But if the death rate changes dramatically, then that can have an impact on the insurance company. So your question is, if you don't have your data, then what do you do? So you use industry level averages, industry level estimates to start with, and then start building your own data capacity, your own data infrastructure, so that yeah, as a company, you can start leveraging your own data in order to take decisions from the next year onwards.
Okay, so this both are data science problem, right?
Everything related to insurance is probably the only domain that will never survive without mathematics and statistics. It cannot survive. So imagine this, right? I mean, in order to figure out how much premium you want to charge, this is really the backbone of insurance, right? I should know how much premium I should charge you. If I don't know that amount, then I cannot be in the business of insurance. Is everybody able to relate to this, please? So out of 100 policies, 5 policies are claiming. Okay. Now, if say I'm expecting them to make a claim of say 1 lakh each, so then I'm looking at a total exposure of 5 lakh rupees, right? How did I get these numbers? So this came from um, general claim rate, right? And this is your general severity. So you have uh, number of claims and you have the severity. So you know this much is there. So how much? So if you're expected to give out this much money, how much premium will you charge? You have 100 policies. You want to make only 100 policies. So you will take this and you distribute the risk over here, right? You will say, I'm going to charge 5K premium from everyone so that according to my calculations, I am most likely to encounter 5 claims, and each claim is not going to be more than 1 lakh rupees. Therefore, I always will be in a position to pay back the money and meet my customer liabilities and expectations. Is that understood?
Yes.
Hmm? Others, others in the group, is it making sense?
Yes.
So far, so good, right? Okay.
One more question.
Yeah.
Um, in the premium that is charged is on the basis of age. So how do they calculate that?
How do they calculate how much premium should be charged?
Yes.
Yeah, coming to that. But not only age, other factors also. So let's have a look. Pure premium is loss by exposure. Loss, what is loss? Loss is basically claim amount divided by exposure. And I mean, I'm sorry. Loss by exposure can be expressed as, if I can put claim amount here, then I can cancel out claim amount, right? And by formula, this is nothing but frequency, and this is nothing but severity. So if you go back to your notes here, you will see number of policies by number of claims. The number of policies is nothing but exposure. Number of claims by exposure. So you have number of claim count or number of claims by exposure multiplied by per per claim how much money has gone out. So frequency multiplied by severity. And so premium is calculated basis predicted pure premium is predicted frequency multiplied by predicted severity. Okay. So there is a separate model for this, and there is a separate model for this. So far, so good. Did I answer your question? How to get the I mean, obviously, you might ask me how is frequency predicted. We will come to that. But at a high level, are you getting the storyline so far?
Here, exposure means the total number of policies.
Yes.
Okay.
Always remember, right, guys? Always remember that whenever you're dealing with any business context, especially in the context of risk, right? Exposure as a term, it defines the extent of, um I would say, the full extent of risk. Okay. In case of banking, the risk lies in giving the loan, right? So therefore, exposure is equal to unpaid money. How much money is unpaid? Okay. And in case of insurance, it's the number of policies. So what happens here is that total unpaid money for a bank is they're waiting to get the money back, and they're not going to, that they will be in trouble if they don't get the money back, right? So always ask yourself what will happen so that the business will get into trouble. So in case of a bank, the money not coming back will get into trouble, will get the bank into trouble, and therefore the unpaid money becomes the exposure. Okay. In case of insurance, the insurance company will be in trouble if everybody starts claiming their money. Correct? Think about it. I'm going to teach you a little bit about generalized linear models, okay, and how that helps in insurance. Why this discussion will help you is because obviously in this class we will take a use case, we will do a project, right? But then there are so many other projects out there, and the concepts of insurance can be applied to diverse cases. We'll talk about that also in just a bit. But first, we'll come to generalized linear models. But the basics or the definitions we just covered: pure premium equal to frequency multiplied by severity. And we talked about what exposure is. We talked about each of these metrics. And these are basic quantities that we should be aware of.
And what type of model is used to solve each frequency severity renewal? What type of model will be used?
Okay, we will be using something called generalized linear models. Okay. Now, everybody has learned regression, but we will do a quick revision of that. So in case of OLS, ordinary least squares, what we have is we have a functional relationship y equal to fx, right? In which y, or the dependent variable, it has a linear relationship with x values. That's what happens in case of OLX. So we are able to write that, okay, y equals 2 plus 3x1 plus 4x2. This is something it's an OLS model. This is an OLS model. So we are able to make this something like this, build an equation like this, because we know that y will have a linear relationship with all the x's. Everybody with me so far? Okay. Now imagine that your hands are tied. You cannot mathematically express the relationship between the dependent variable and the independent variable in this format. Then what do? Suppose y does not have a linear relationship anymore. Imagine that y takes only two values, 0 and 1, and you have n rows of data, right? N number of rows of data you have. So y does not come from normal distribution. Y comes from binomial distribution, where parameters are NP. N is nothing but number of data, number of rows of data, and P is the average rate of success. So out of n rows of your data, number of rows where target equal to 1 and number of rows equal to where target equal to 0, you will be looking at all of that and essentially calculate the percentage of rows where target is equal to 1. That becomes your probability of 1, right? So therefore, y can be said that y belongs to binomial distribution with parameter np. Now, in this kind of a context, right, where y comes from binomial distribution, you cannot expect to write something like this. So what do? You introduce a certain function called a link function. You say that, okay, I know that directly I cannot write this y equal to a1, a plus b1, x1 plus b2, x2, directly you cannot write. Therefore, let me bring in an intervening function called link function, and let's use that link over here. So in case of logistic regression, the link function is called logit link. This is the logit link. Okay. So you can't say y equal to a1, a plus b1, x1 linear combination, but you can say that logit of y, you can express the logit of y equal to a linear combination. That you can do. Okay. So you can't say that y has a linear combination for sure. But if you apply the logit function on y and say logit of y has a linear combination. Okay, so this becomes your, it's a generalized linear model. So once the moment I write this log of y by 1 minus y equal to a plus b1 x1 plus b2 x2, this one. So this is an example of GLM. Now in case of frequency, we use Poisson regression model and we use gamma regression model for severity. So they are a different link function, mostly log link functions, but there's a separate kind of models called Poisson regression model and gamma regression model. Both of these models, they are going to be outside of our discussion right now, but we can check. I we can check online, I think. Just give me one moment. Let's go here and check. Hmm, yep. Yeah. Are generalized linear models with the logarithm as the canonical link function. So it's basically log link. Okay. So log link will be there. Yeah. Log of y will have a linear relationship with. There you go. You can do GLM in R, or you can do GLM in this thing also, Python also. Essentially, um, the log function will serve as the link function. Okay, for Poisson distribution. But for gamma regression, one second. Yeah, it's called the identity link. Yeah, the PDF got downloaded. Yeah, this can be a good resource for you guys to go through generalized linear models. Just a bit. I'll share this. Where is the chat window? So for you've got simple linear. They are also family of all these things. Identity link is case of gamma. So you can do some more research on this. But the thing to note here is that in the context of today's discussion is that there are other models other than OLS models or even normal regression models which are used in case of insurance, and that's why this is a very data science heavy industry where especially stats related work is like heavily done. because you have to come up with all these things. Um, Specific models for predicting specific outcomes. Now, why are we choosing Poisson regression for number of claims? Loss curve for claims. You can see that it follows gamma distribution. So we can make sense. But number of claims is, it is supposed to follow Poisson distribution. So always remember that Poisson distribution is used to estimate number of events. It is always used to estimate the probability of number of events. So basically, that is why you are using Poisson regression process here for frequency. Now, coming to our problem statement, the problem statement that we are dealing with is basically that people have almost they're at the end of their term as a customer, and they have to basically renew their premium, right? So what are they going to do? How can you figure out who's likely to get a renewal done and who's not likely to get a renewal done? So that is the statement. Like, can we predict which customers are likely to give us, renew their policies, and which customers are not likely to renew their policies? So that's the statement, and then I'll walk you through the data to see, discuss the different features that are there, and explain the approach that we will take. But before that, I just want to pause and see if you have any questions.
Can you please explain this graph, like loss curve for claims, how to read this?
Okay, so the only way to do this is in two sentences. Basically, majority claims will be of small amount. Okay, few claims will be large. That is how you should read it. So this is where large claims are taking place. One moment. This is where larger claims are taking place, right? Large claims. And this is where smaller claims are taking place. So you can see the number of people who are claiming small amounts are from here to here, but only people who are claiming like big amount of money are only this much, right? It's a right skewed distribution. Making sense?
Yeah, thank you for this.
Where have you seen this distribution in your stats classes? What is the in hypothesis testing, you would have done chi-square test. Remember, all of you would have done chi-square test. Chi-square curve is also like this, because chi-square is a modified gamma distribution curve. So the chi-square distribution is derived by summing up independent gamma variates. So that's why chi-square curve will also be something like this. But the point to note, I mean, forget about the curve and the distribution. The point to note is that um, majority of claims are going to be small amount. Only few people will claim large. Let me take an example. This will clarify everybody. Say all of you have cars, okay, and you have insured your cars. Can everybody relate to that, please? Okay, right. Now it is likely that some of your cars will get some damage during the year, so you might just you know get some claims. That is possible, but how much chance is there that some of you will have your car completely smashed to bits, like it is beyond repair? Very less chance, right? Very
Yeah.
less. Out of, like, I mean, some people might, unfortunately, like those. I hope it never happens, but also, I mean, just think about it. People will say my car is a total loss when, say, some truck has come and literally smashed, some trailer has literally, bulldozed your car and gone away, like, something like that. There was a picture of, I think, Kia Seltos, where the Kia Seltos broke into two halves. That is a total loss. There was a picture of a Maruti Baleno once after it was, I think shortly after it got launched a few years back, there was a very bad accident. It happened close to Punjab. I think it was a complete loss. But I mean, think about it, right? But those are rare events. So therefore, large claims are not very common, but small claims are very frequent, very, quite common. That is fine. So that is why this is the nature of the graph. It is because of that reason. Is it making sense, everyone? Okay. All right. So now we are going to come up with a implementation strategy, but let's have a look at the data to get a feel of the overall data to see what kind of variables are there and what can we expect from the data. Uh, yep. Okay. Looks like there is an issue. Let me download this stuff once again. But why would that be an issue? Mm, yeah. Yeah. Okay. We have it. All right. So you've got all the customers here. How many customers do we have? We've got data for 9,000 odd customers. Okay. Not a very large data set. This is a data set that these guys in IBM has come up with this data set for practice purposes. So that's fine. So we've got about 9K odd customers. Then we know where they live, which part of the US they live. That's there. Now, the other part comes, the other feature contains lifetime value. Lifetime value is a marketing concept where when a customer is acquired, then you can try to project that if the customer is with you, you define something called a lifetime. That okay, if 5 years is a lifetime for a customer. Okay, now if the customer is with you for 5 years, then how much value can you derive out of the customer just because the customer spends like that much time with you? So it becomes customer lifetime value. Now, now in the past, whether somebody has responded to a renewal offer or not, that is there as a response, yes or no. Then you've got the nature of coverage. So some coverages can be very basic. It does not come with a lot of features, not a lot of riders, etc. Sometimes, you might come across things like, if you take basic coverage, then on roadside assistance is not included in your coverage. I don't know if some of you may have come across um, this in your car insurances, but basic coverage does not essentially contain any frills or any extended services. Now comes extended as another type of coverage where you have slightly, few additional facilities and a few additional riders. Then the third comes premium, where you can expect more one-on-one kind of service, where you could potentially have a concierge for your insurance requirements. If you get into issues, then you don't have to call a number where you have to be in a queue. There can be a dedicated line given to certain these segment of customers where the queue is much shorter. So those kind of things can happen. Basic, extended, and premium are the three types of coverages that is provided. Now comes education of the person who has insured, the insured individual. That's there in various degrees. So let's have a look at what are the levels of insurance. So one of my sorry, education. So one of my favorite ways to look at the data is just, select it all in Excel, go to insert, go to a pivot table, and simply explore the data quickly. So if I just stick to the classic layout, I can quickly see what is going on. Although in Python, we'll be doing it systematically, but in case of states, so let's say I bring it here. So I can see that people who are insured are from these 5 states only. Awesome. What's the overall response rate? If I want to find out yes or no, then let's get the number of customers. So these many people have responded, these many people have not responded, right? So 1308 typically divided by 9134, 14% is my response rate or chance of success to a prior campaign. So that is what I'm going to use for any further analysis. Now, if you bring in lifetime customers, I'm sorry, um, let's get rid of count of customers. Let's begin lifetime and let's begin response over here. Yeah. And if I double click on this and I get average, I can then compare the numbers. So we can see that whether you're a responder or you're not a responder, it doesn't really matter. You can essentially, you're similar. The lifetime value is not going to help us identify who's going to respond, because people who have not responded, they have slightly higher lifetime value, and only very slight difference. The difference between these two values are not that much. So that doesn't help us. Now comes coverage. So we bring it here. Can we bring in the number of customers? We can see what's going on. So majority of the responders are from basic coverage. That is because most of the customers are from basic coverage. But if you want to find out um, chance of responses, so let me just double click on this and show values as percentage of columns. We can now see that what's the overall response rate, right? So 14% is the overall response rate. It doesn't really change. So by coverage, whatever coverage you choose, right, response rate, chance of response doesn't really change by coverage. Can all of you see what's happening here? Okay. I'm sorry, I was just drinking some water. Now let's see by education. Does education make a difference? Education makes a difference. Some extent, right? We can see doctors are more likely to renew their loans, renew their um, policies. High school or below, somewhat lower, but again, not a earth-shattering difference, right? It's not like uh, it's very, very, stark as a dis as basically chance of success as compared to this. Now look at this. People who are retired seems like they are phenomenally higher. The chance of renewal is much, much higher. In fact, it is so much higher that it is like what, 5 times higher, right? So 70 divided by 14, 5 times higher. So it's 5 times more likely for the retired people to renew their loans. Now, this is good insight because employment status can potentially be a good predictor or discriminator. But yeah, this is not feature selection that we're doing in Excel. Of course, if we have to do this whole analysis in Excel, we could have done feature selection this way. But for the purpose of discussion today, where we're exploring the data, we are looking at various features and their combinations with the response variable. So yeah, we are exploring. So it looks like retired can help you, but of course, we need to put this through a select k best, etc., to see from a chi-square perspective, does it make sense? So is the difference between this and this statistically significant or not? So that is something select k best will do for us. But overall, I think this has given us some clue that okay, if the individual is retired, then chances pretty high that renewal will probably happen. Okay, now let's look at something like marital status. This actually becomes an important feature because, but very surprising that you know this one is not showing any kind of, I mean, whether married or single. It was expected that for married individuals the renewal rate should be higher, but it's not the case. For divorced, actually, it turns out to be a little bit better. Um, Monthly premium. Let's see how much is the monthly premium, and this is again showing values as number of. Okay, no, it's fine. So we'll just put it in dollar terms and take the average because we are interested in per customer all the time. Never take any. So if you look at these numbers, right? If you look at these numbers, then you can see you might. Okay, this is an example of. I want all of you to pay attention. Look at this number, sum of premium. What do you see? That people paying a higher premium, the chance of response goes down, right? How would you interpret this particular stuff, guys? How will you interpret this? This is data interpretation question, okay? So how do you want to interpret this? Is there any difference, like if people who are responding to a renewal offer, uh, are they very different from a premium perspective or not? You are looking at this number. Can you also look at this number? This is very critical, everybody. So it is not enough to look at just this number and make a decision. Okay.
Yeah.
Whenever you're looking at data, right? Yeah. Always see what's the size of, basically how many observations are contributing to that number. So 7,826 customers are contributing to a total monthly premium of 728,327. Now these guys, 7,826 people have not responded. So on an average, what has happened here is that this is the average number, right? That on an average, I mean, if you take a, if you take basically take per customer basis, then that's the total number of total amount of premium that has come. So $93 has come from one single customer who has not responded as a monthly premium. $94 has come from people who have, I mean, on an average, people who have responded. So there is no difference between these numbers, not much difference. So monthly premium cannot be a determinant for you to decide that, okay, these people have higher monthly premium, let's say target them or no. So monthly premium cannot help you in targeting people for renewal policies because average monthly premium does not differ. Is that very clear?
But Aditra, here, if we'll go with the K-bins analysis, right? So it could have give a good variable saying that monthly premium is a good variable to include. But this is kind of an custom field that we have to create, right? To look at that, okay, you have to check with the count of customer then.
Monthly
No.
premium.
So
No,
when we
no, no.
do,
So here is the. Let's just do this. Okay, let us do this. Okay, I will try to do something like this. Let me create a column called target. No. So 0, 1 gets created. Okay, average should be 14%, something like that. Yeah, it's there. Now let's go to monthly premium. Right now, um, this I keep forgetting. Yeah, how to do deciles in Excel. Allow me a moment, okay? Let us find this out. Percentile, cell range, percentile. That's what I did. We have shown 20 values here. Okay. Okay. Let's see. Okay. So let us take this aside and let's create a column called decile. So what we do is we create percentile for all these cases here. F4, fix it up, and then we say this divided by 10. So this is 64. These are the cutoffs actually. Okay. So if this one is less than or equal to this number, which is, then it becomes first decile, else if in an AND scenario, if this is greater than this and less than this, right? So we will have to say AE2 greater than AI2, which of course has to be fixed. Guys, bear with me a moment, okay? I'm trying to answer her question actually. I hope it is okay with everyone. I'm sorry, I'm trying my best to answer the question. Did I catch your name correctly? The person who asked me the question.
Yeah.
I didn't get
Yeah,
your name.
it's okay. I mean, it would take a time, then yeah, it's
No,
okay. We can.
just give me 5 minutes. It's okay. Just give me 5 minutes. Okay? No worries. If A2 is greater than this one, wait, let me create some space here. Actually, I'm not able to figure out the columns also. Let us, yeah, if this one is less than or equal to Let's see if it works. So all of us is in decile. Okay, we can see only 1,000 observations have gone into one, which is fine, which is making sense. So now another if condition will come in and bracket open, same thing, A2. This time it is greater than. Actually, why am I even doing this, right? I don't have to write all these statements. Just directly say it is less than or equal to 64. Then one if and A2 is greater than 64, comma, A2 less than or equal to 67. Then I give it 2. Otherwise, greater than 67, comma, A2 less than or equal to 70 becomes 3. Becomes 4. Then you can use this template later on also if you want to do this kind of analysis in Excel. I'll be sharing this template today. I don't know if you guys would like to have it. Mm, So instead of anybody has any questions in the meantime, I can answer while we are doing this. Nope. All right. No worries. Mhm. This becomes a challenge. I think I must have made some mistake in the formula in a rush to do it. In these situations, guys, it's always good to go to your good friend Notepad and keep a copy of these cases or formula, right? You don't want to be writing it again and again. Now, let me see what went wrong here. If I were to do 1 and 2, can I do it? Yeah, then this was okay. Then what happened?
In last few statement, we have not written and, I guess.
Yeah, you're brilliantly right. Absolutely right. And that is where it has become a problem. Come on. Okay. Oh, thank God. Thank you so much for helping me out here. All right. So let's do a lookup. Let's do a lookup. Okay. Premium. Okay. If you want to work like this in Excel, you can pretty much do your bivariate analysis like this only. In fact, if you guys are interested, I I'm more than happy to show you how you can use Excel for classification purpose. If you guys are interested, let me know. Would you be open to learning how to do scoring, classification modeling, or some, yeah, you can achieve the same objective using Excel also. Let me know if that makes sense. Okay, so now let's see. Premium this, we bring it here. Come on now. Yep, pretty much the same premium. Okay, now we're supposed to take average premium. That will change. Yeah, it will. Yeah, it has to be same because ultimately you're pretty much the same number of customers getting captured. So details are fine. In Python, of course, it can be a little bit different here and there. Some changes can happen. But if I take this out for now, okay, I am interested with the target. Where's my target? Yeah, average target feature. So let's get rid of this. Get rid of this. Hmm. So how does this graph look? Does it look good from a premium predictive purpose? Not that good, no? Yeah, no. I mean, like, look, there is no discrimination because ultimately 14% is the rate of success, right? So there is no premium bucket where you are superbly higher than 14%, except for this bucket, somewhat higher. This one. If you do a data labels, the add data, you can clearly see 14% is the average event rate. So in no such case where it is much higher. So and there is also no slope or discrimination that is shown by this variable. Okay, we now have the target variable as well. Let's bring in gender. Again, gender seems like a again gender not a good predictor. You can see we bring in gender here. Um, See, 14%, not very different from each other. This is these are two. You can see that gap here is 14.17 versus 14.48. That's why there's a little bit of gap, but overall there's not a lot of gap, right? So gender is again not very promising for now. Then what is it that we are looking at? Months since last claim. Okay, months since last claim. Because it's a continuous variable, we can't actually use this like a categorical. What we're going to do is we are going to have average month since last claim. Okay, we can get rid of the graph if required, or maybe remove the target here, bring in response yes or no. So here we can see that month since last claim. Uh, the more I mean, the if the time has if it has been a long time since the claim has been made by the customer, then chances are higher that the individual uh, might actually respond. Okay, so how many months since last claim? So some changes here. So 14 months on an average. 15 months is the month since last claim made, but people have responded. You know they've also claimed recently. So it is logical and it is very intuitive because it means that a customer is happy when the claim was made, the money was given out, and the customer was pretty happy. So they actually are more likely to renew their portfolio, renew their the policy. Now, months since policy inception, how much time has it been since you're a customer? So that is the metric here. So let's see, months since policy inception. It will again we have to take the average. It is not very different, right? 48, 48. Tenure is not playing that much of a role. Number of, let us get rid of the, no. Number of open complaints. This should be, yep, see, you can see it here, right? Number of open complaints. This actually should make a difference. The number of open complaints, I mean, is lower in case of people who have people who have responded versus people who have not responded. If you take a sum of number of open complaints, you see the 474 complaints are coming from people who have responded. I mean, only 474 versus if there are a lot of complaints. Of course, this is again intuitive because if customer is happy, then they will come back and take your services again. Okay, number of policies. Oh, it shows the total number of policies here, which is again lower number of policies. This can also be good in terms of predicting chance of responses. What else does it have? Renewal offer type. Yeah, this can be interesting. Let's have a look. Let's get rid of the graph. Let's bring in the number of customers here. Okay. So what do we see? We see that out of 9134, chance of, let's have a, okay, let's express these as percentages of columns. Can you see how I'm using Excel for deriving insights? Is this something that you guys normally do, or is this completely new for a lot of people? You would want training and guidance on this. Can I know what is this scenario?
This is something new.
Something new. I hope you're enjoying what is happening. Like it's not using any program per se or any programming language, but merely using Excel. But can you see the power of Excel, right? In a very short amount of time, you're getting an overall good sense of the data, right? So would you like me to put together a project in which I use Excel and solve a classification problem? There's a separate kind of modeling called heuristic modeling that can be done on Excel. But it involves bivariate analysis, and it involves finding out variable cutoffs and applying those variable cutoffs. If you would like to let Apurva know, and I can put that together. Okay. Offer two. There's something about offer two. People like more of offer two. You make offer two, people like almost like double the chance of responses. Offer one is also not bad, 16%, but offer three and four are not liked by customers pretty much, because majority of people who have been offered offer 3 and 4, out of 100%, 98% never responded in offer 3, and nobody liked offer 4. So 3 and 4 are clearly not working. 1 and 2 are working. 2 is the best, followed by 1, then 3, and then 4. 3 and 4 are equally bad, but 2 is the best, followed by 1. Make sense?
Yes.
So
Yeah.
similarly, let's look at which sales channel is good. Sales channel. Agents are always going to be good. Human to human touch makes a lot of sense. Call center, how many times do I like it when Policy Bazaar calls me? I don't like it too much, right? Call center, web, or the advertisements, unless and until I'm really looking for something, it might not actually help me renew the uh, policy. So agents are slightly more effective in terms of 19% probability. Overall, you have 14%, right? Other than agent, pretty much all of them, they bring down the probability of success even from 14%, right? It's all 11 and 12. So agent is standing out. So if we have a one hot encoding for agent, that can be a good predictor, but not a very powerful predictor, but still a good predictor. Vehicle class. Let's see what kind of vehicles are. Um, so here's the thing, right? If your car is super expensive, you would ideally want it to be insured as much as possible. So, I mean, you would kind of stick to the same insurance because uh, especially if you've got good service. So we've got luxury. cars. So these are, yeah, it's a little counterintuitive with luxury cars, but in case of sports car, it looks like chance of renewal is higher. Let's bring in something like, uh, wait, we also looked at some stuff here, right? Number of open complaints. Can we bring that here? Hmm. So we get rid of this. We bring it over here. Yeah, 1 minute. Just 1 minute, guys. Get rid of this and show the average. Okay, so express this as simple number. Okay, higher complaints are seen in larger cars, right? So chance of success. Let's see the chance of success. Chance of success marginally improves when complaints go down. Again, it is tying back to the same story that we saw, that if you're kind of happy as a customer, it makes sense for you to. So always try to make sure that your data makes intuitive sense, okay? Because in interviews or in any kind of project presentation, this actually helps to show that, yeah, I have checked on intuitive size as well. In case of large cars, more likely smaller cars, they're going to shop for insurance. Whoever gives them the lowest premium, they will go with them. Okay, total claim amount. Is it going to change on an average? On an average, total claim amount is highest in case of smaller cars, and this is the most unprofitable part of the business, where smaller cars are being insured. Claim amounts are, on an average, are higher as compared to larger and mid-sized cars, but they are also not coming with good renewal rates. Renewal rates is 11% as compared to the average of 14%. So this is the most unprofitable part. However, this is the most profitable part. So larger cars makes a lot of sense. You ask the insurance company to pay less money to you and also give them repeat business by doing renewal. So this is good for them. This is good. And this one is not good. So when we create a strategy in Python, we'll try to do it using, vehicle size can be a consideration for that. Okay, what else did we miss? Type of policies. All right, let's have a look. So in pivot table, you can also drag variables like this, and you could do a interaction analysis. See, in large cars, we can see what kind of policies you have. The corporate auto is a policy type, and let's get rid of this total number of companies. So 19% is the overall renewal rate with 434. So that is standing out as the most important. This is the most profitable part of the business, where you've got large vehicles under the policy type of corporate, where renewal rate is quite high. In case of small, see, small is overall bad. If you look at, if I just take it away, right? Small overall is bad, correct? But if I bring in policy type, then within small, special auto, whoever has taken special auto becomes good. I mean, from a renewal perspective, renewal, at least chance of renewal is quite high, 20%. But also it's costly because they are going to charge, and they're causing the majority of losses, 529 per customer. Okay. So this is what we call as interaction between vehicle size and policy type. Now, why would we want to use machine learning? Because machine learning models can automatically identify these interactions, especially decision tree based models, random forest boosting decision tree. They can all automatically identify these interactions. They're able to capture that, and that's why we prefer to use ML in these situations. But if you were to do this analysis in Excel, then it could have been nice to see. I mean, it would be kind of manually, but we would spend time exploring the data and try to find out these insights, and then use these insights to create some sort of scoring mechanism. Okay, so pretty much we've explored our data. I think we've missed out on one thing, which is called policies. Not sure what. Okay, these are uh, type of policies, and then again the policy, exact policy as well, right? So if we remove the subtotal here, we can see small, special auto, special L1, special L2, special L3. All of them have pretty high renewal rate, but also pretty high cost or total claim amount. That's fairly high. In case of large corporate L1, L2, L3, if you want to drill down, if you want to drill down within the policy type, you could use the policy column as well. But policy column and policy type are largely, they're all correlated because corporate auto is broken down into three parts. So what I would typically do is we can get rid of policy type variable directly, right? We don't want to use it right away. We can just use policy as a feature. All right, then. Thank you very, very much for meeting me this evening. Have a great rest of your night and see you again on Thursday. All right, then.
You.
Thank you very much.